Now we're gonna find the limit of t arcsine of 1 over t as t goes to infinity. The first thing that we need to do is we're gonna check. We're gonna just plug in the values and see what happens. Here, as t goes to infinity, t will go to infinity, and the arcsine of 1 over t will go to 0. So we have infinity times 0. We can't conclude. Okay? Next, what we're gonna do is we will use or we can write this one in a simpler form. We can write t arcsine of 1 over t as arcsine of 1 over t over 1 over t. And we see that the limit now, the limit as t goes to infinity, so here we have 0 over 0. So we have this undeterminate form. We have 0 over 0. So we can use L'Hopital's rule in this case. Okay? We will simplify this problem, and we see that we can find this limit by two methods when we simplify the matters. Okay? So let's change this 1 over t to some x or y. Let 1 over t or equals y. So as t goes to infinity, y is gonna go to 0. 0 from the right. So we have the limit as y goes to 0 from the right, the arcsine of y over y. Okay? Let's check one more time here. We have 0 over 0. Okay? But this is a simpler form. We can use L'Hopital's rule. Here we know the derivative of the, so this is equal to the limit of the derivative of the arcsine is 1 over 1 minus y squared over the derivative of y, which is 1. So therefore we have the limit as y goes to 0 from the right is 1. So in this case we get the limit needed. But this is one way. We can solve it in a different way from here too. Okay, let x be the arcsine of y. We assume all the conditions of existence of x and y are satisfied. Y close to 0, and the x and the arcsine are very related now by this value here. Okay, so as y goes to 0, x is gonna go to 0. So it's the same here, you know that from the graph. So x is gonna go to 0, and the arcsine of y is just x. For y is the sine x using the inverse function. Now we can write this one as the limit as x goes to 0 of 1 over sine x over x. And we know this one here. We know this limit here. We know it's 1. Therefore, we have proved in two ways how to find the limit of this function here. So this limit is just 1. Okay? We could also have said something about the domain of definition, but it's clear from here using the composite function. We did a similar problem for the arcosine, and you should be able to do the same thing very quickly using the same technique. So this shows that the limit that we are looking for is 1, and therefore this ends our video because we've done everything that we need. Thank you very much.